watt. Another example. Batteries are rated in terms of ampere hours. For example, a battery that can supply a current at the rate of 5 ampere for 10 hours is rated 50 ampere hour. When you go buy a battery for your car, actually the batteries are rated in ampere hours. Do you know how much is the capacity of the battery that you use in your car? How many ampere hours? Well, normally a car battery is about 60 ampere hour. It means your car battery can supply current at the rate of 1 ampere for 60 hours, or at the rate of 2 amperes for 30 hours, or at the rate of 20 amperes for 3 hours, and so on. Now remember, when you start your car, the starting coil will take a large amount of current, but for a very short time. Okay. Now, what is the total energy in kilowatt hours stored in a 12-volt battery rated at 60 ampere hour? At the rate of $0.08 per kilowatt hour, what is the value of the electricity produced by this battery? Well, the battery is rated 60 ampere hour means that if the battery supplies a current I ampere for T hours, then I times T equal to 60 ampere hour. Ampere hour. I ampere times T hours. You see, 3 ampere times 20 hours is 60 ampere hour, right? Okay, so I current in ampere multiplied by the time in hours is 60 ampere hour. And energy equal to VIT, we have been using this equation. Power is V times I multiplied by the time will be the total energy delivered during that time T. Therefore, energy equal to VIT and IT equal to 60 ampere hour. So the total energy the battery will supply will be 12 volts times 60 ampere hour. That will be 720 watt hour. In other words, you can see, use the unit correctly. 12 volt times 60 ampere hour will be 720 watt hour. And that will be 0.72 kilowatt hour. You see that? Watt hour becomes kilowatt hour by dividing by 1,000. And a kilowatt hour is a commercial unit. Now, the value of the electricity therefore is 0.72 multiplied by 0.08. That is 0.058 or 5.8 cents. That means each time that battery is fully charged, it will contain electricity worth about 5.8 cents. But remember, your car battery is continuously being charged and recharged. So during the lifetime of the battery, you will be storing hundreds of times worth this electricity in your battery. Let's do another problem. A 15-watt electric heater is used to heat 100 grams of water in a beaker. If 75% of the heat generated is used for heating water, how long will it take for the water temperature to change from 20 degrees Celsius to 35 degrees Celsius? Well, here we have heat generated electrically and that heat is used to heat up water. That means we are going to use two principles. The amount of heat generated by an electric heater is RI squared T or VIT, any of the equations. And the amount of heat used by water to increase its temperature is mass times specific heat times change in temperature. You forgot that equation? We are now going to combine these two. Okay, let's pick our data. The power is 15 watt. That is the power of the heater. It means the heater will produce 15 joules of energy per second. The mass of water you want to heat is 0.1 kilogram. Initial temperature of water is 20 degrees Celsius. Final temperature of water is 35 degrees Celsius. And we want to find the time taken for water to increase its temperature from 20 degrees to 35 degrees. So let's start by saying let T be the time taken for the temperature to increase from 20 degrees to 35 degrees. Alright, if T is the time taken, what is the amount of energy used during that time? What is the amount of energy produced during that time? How much energy is produced in 1 second? 15 joules. Therefore, how much energy will be produced in T seconds? The quantity of heat generated is Q equal to VIT, or simply power multiplied by time. VI is the power. So that will be power multiplied by the time. The power means the energy per second. You multiply that with the time during which the appliance is used, you get the total quantity of heat produced during that time. That will be 15 watt times T seconds. That will be 15 T seconds. Now, not all this energy is used by water. Only 75% of this is used by water. So what is the amount of heat actually used by water? Is 75% of this quantity. The amount of heat used in raising the temperature of water is 0.75 times 15T. 75% of 15T. That will be 11.25 T. This is the quantity of heat produced by the heater and delivered to water. And this amount of heat is used by water to increase its temperature. That means the amount of heat used by water to increase its temperature is mass times specific heat times change in temperature. Alright, what is the specific heat of water? You remember that one? It's 4,180 joules per kilogram per Kelvin. So this 11.25 T must be equal to mass times specific heat times change in temperature. Alright? If C is the specific heat capacity of water, the amount of heat required to raise the temperature of m kilogram of water from theta 1 degree Celsius to theta 2 degrees Celsius is mc delta theta, mc times change in temperature. We know the mass, we know specific heat of water, we know the change in temperature. So the mass is 0.1 kilogram, specific heat is 4,180 joules per kilogram per Kelvin. The change in temperature is 35 minus 20, and that will be 6,270 joules. Now I have colored these two quantities similarly. That means this quantity of heat produced and supplied by the heater equal to this quantity that is used by water. So 11.5 T equal to 6,270, therefore T equal to 545 seconds, that is 9.1 minutes. A typical kind of problems, you must know how to solve these kind of problems. Okay, well, this has been a good 3-part lesson. I want you to review all the concepts we have developed. We developed the concept of electric current, electric power, and how to use the concept of Ohm's law, and all these to solve problems. The internal energy of a cell. So please review all these and make sure that you can do all such problems. And I will get back to you with the next lesson a little later.